Hello, we are from Group 5.
Hello my friend, my name is Andika Rizky.
My name is Ivinia Mutia Andiani.
My name is Puput Maswa Agustini.
My name is Putri Paramita Diani.
And we will explain you about Vickers and Knoop hardness test method. So, stay tuned. Okay, we are have 6 contents that we will explain you about Vickers and Knoop hardness test method. They are definition, how to read the values, procedures, method and applications, comparison, and advantage, disadvantage. Hello, I'm Putri. Now we talk about Vickers hardness test method. So, the definition from the Vickers hardness test is a static hardness test method used for both macro and micro hardness testing. And it also can be further characterized as follows. 1. The Vickers method has a test load range from 1 gram force according to ISO, respectively from 1 gram force up to 120 kilogram force according to ASTM. It means that this method can be used for hardness testing across all load range. It means too from the micro to the low load through to the macro range. 2. It's also the one of the standardized procedures like ISO 6507, ASTM E92, and ASTM E384. 3. The Vickers method is an optical method, which means that the size of indentation left by the indenter is measured to determine the hardness value of a test specimen. 4. The Vickers method is better for small, rounded specimen or square indentation. Okay, thank you. Back to Putri. Now I will explain you how to read the value from the Vickers hardness test. So, the Vickers hardness test value consists of the following components. Like first, the numeric hardness value between 1 and 3000. 2. The two letters are HV standing for hardness according to Vickers. 3. The applied test load in kilogram force. 4. The last one, according to ISO 6507, the dwell time of the test load, but only if this not between 10 and 15 seconds. Okay, let's go to the example. So, we have 640 HV 30. It means 640 as hardness value, and the word HV as per Vickers. And then 30 as with test load of 30 kilogram force, or the test for the test force of 294.2 Newton. Okay, the second example is 610 HV 10 slash 30. It means the 6010 as hardness value, and the worth of HV as per Vickers. Then 10, it means hardness value will be test load with test load of 10 kilogram force, or will be test force of 98.07 Newton. And then 30, it means the dwell time to test force outside recommended duration. In this case, 30 seconds. Okay, thank you.
Hello, my name is Puput Maspo Agustini. Now I will explain about procedure Vickers test. The Vickers test is static hardness test method used for both macro and microness testing. Equipment required about Vickers test procedure: 1. Vickers hardness tester. 2. Pyramid indenter. Procedure Vickers test: 1. Set the machine to the required stage of the test load and whirl time. Place the specimen carefully on the testing table. 3. Bring the object to the set position. 4. Turn the hand wheel slowly in the clockwise direction so that the specimen gets focused on the front screen sharply. 5. Bring the object back to the set position. 6. The indentation is now projected on the front focusing screen. 7. Measure the diagonal along both the axes of the impression and record them. And then is a formula and calculation Vickers test. Heavy equal to F sin 136 degrees divided by 2 divided d square.
Hello, I'm Putri, and I will explain about specimen requirements. So, if we want to use the Vickers hardness test method, we should meet the following requirements like this. First, in micro hardness testing, the specimen should be polished. Or in macro hardness testing, the specimen should be precision ground. 2. The specimen should preferably be clamped strongly, so it cannot move during the testing process. And this is a practical tip that we can measure with nose corn wraps with suitable test and feel. And in addition, to avoid affecting the test result, care must be taken to ensure that the test is not disturbed by any shock or vibration.
Evie, Now I want to explain about Vickers methods and applications. So, depending on the magnitude of the test force according to ISO standard, pause. What is ISO? So ISO is an organization called International Organization for Standardization. So ISO is not a shortness of something, but actually is a word can come from Greek, which is isos, which means same. Now continue. The Vickers process can be subdivided into three hardness testing log ranges. The first is micro, and then low load, and then conventional or macro hardness range. As you can see on the table, the micro hardness range used method like between the range is between HV 0.01 until 0.1, and the indenter is diamond pyramid 136 degree, which is the shape of the Vickers hardness test. Is a pyramid-shaped diamond of 136-degree angle, and in micro, the test force that used is between 0.098 newton until 0.98 newtons, and the applications is for the structural constituents or very thin layers. So basically, in the micro hardness range, usually it's only like from a few grams to several kilograms. Meanwhile, the macro range, uh, the Vickers lots vary from 1 to 120 kilograms. So in macro range, the indentations should be as large as possible to minimize errors in measuring. Next, I want to explain about factors for the selection of the correct test force or test lot and test method. The first is the specimen size. So the minimum space between test point and from specimen edges must be observed. It means that the sample cannot be too small. The second is the specimen thickness. So the specimen thickness must be at least 1.5 times the indentation diagonals. This one is the diagonals of the indentation, and so the minimum specimen thickness must be between 0.085 and 6.5 millimeters. The third is the surface quality of the specimen. So like the surface of the specimen should be polished, especially for the very low test loads. A good specimen surface is important for a correct measurement result because the Vickers indentation is very small in this case, so the smallest of irregularities or the smallest thing really can affect the measurement result. Thank you.
Okay, I will continue what was said. Now I will tell you what are the advantages and disadvantages of testing the Vickers method. One advantage. The first can be at least to object with thin thickness up to 0.006 inches. Second, has only one type of inductor test solved to hard material. 3. Reading of traces can be done more accurately. Why? It's more accurately. because its accuracy is quick length which can be up to 0.006 inch. Fourth, a relative non-descriptive type of testing. 5. The Vickers method can be used on almost all methods. Next, dispensers. The first, Vickers allow them to determine the value of choice. Second, overall, the testing time is long. 3. Arrange optical diagonal tracking. 4. Open object must be well prepared. Conclusion on testing methods that is due to the accuracy of our accuracy is very good. Therefore, the examiner must check slowly because now the greater the accuracy, the longer the accuracy check because the manual is difficult to set the cell as magnet.
Hello, I'm Putri. Now we move to Knoop hardness test method. So, the definition from the Knoop hardness test method is a static hardness testing method which was developed as an alternative to the Vickers method and is used in particular for the testing of thin layers and brittle materials. This Knoop method can be characterized as follows. First, the Knoop method has a test load range of 1 gram force to 2 kilogram force according to ISO and ASTM. It means that this method can be used for hardness testing in the micro and low load range. 2. It's also the one of the standardized procedure like ISO 4545, ASTM E92, and ASTM E384. 3. The Knoop method is an optical method. That means the size of indentation left by the indenter is measured to determine the hardness value of a test specimen. 4. The Knoop method is best suited for use with small, longish test specimen because their long and narrow or elongate test indent. Okay, thank you.
Okay, this is Ivy. Now I want to tell you how to read and represent a Knoop hardness value. So, what are the components of a Knoop hardness value? First is the numeric hardness value. Second is the two letters, which are H and K, standing for hardness according to Knoop. The third is the applied test load in kilogram force. And the last is according to ISO 4545, the dwell time of the test load, but only if this is not between 10 and 15 seconds. So basically, we only put the duration of the time if it's an uncommon practice, which if it's not between 10 to 15 seconds, as example like 20 or 25. Yeah. Now I want to give you examples of Knoop hardness value. So the first example is 870 HK1, and the 870 is the hardness value, HK as per Knoop, and the 1 it means with test load of 1 kilogram force, or if we want to convert it into test force, we will get 9.807 newtons. How do we convert the test load to test force? So we have to multiplying the value of test load, which is 1 here, with g, or refer to the acceleration of gravity. The value of g is 9.8 meter per second squared. So we have to multiply 1 with 9.8, and we will get the test force value in Newton. And the second example is 870 HK1 per 30. So same with the first example, the 870 is the hardness value, HK as per Knoop, 1 with test load of 1 kilogram force, and this one, the 30, is the dwell time to test force outside recommended duration. In this case, 30 seconds. As you can see, 30 is not between 10 to 15, so of course we have to put it in a value. Thank you.
Knoop test procedure. When the Knoop hardness test on optional method, the size of indentation left by the indenter is measured. 2. The large in the indent left by the indenter at the indefinite test for in the surface of a workpiece. The softer the tested material. 3. The Knoop method is particularly suitable for a thin and narrow specimen and for testing brittle material. According to the standard, the maximum permissible application time for the test for is 2 to 8 seconds. 4. In the Knoop test method, the indent must be positioned such that there is sufficient clearance from the specimen and between the individual indents. The tests for as the Knoop method are very small. Consequently, the indents are also very small. Therefore, particular attention must be paid with this method. Test free from shock and vibration that distort the measurement result. And then formula and calculation. Knoop test procedure. Heike constant X test for F divided surface of the indentation.
Hi, back with me again, Ify. Now I want to tell you about specimen requirements for the Knoop method. So just like the Vickers method that my friend explained earlier, when using the Knoop hardness testing method, it is so necessary to prepare the surface of the specimen that want to be tested. Because the specimen surface quality requirements for Knoop method are much stricter than those for the Rockwell method, which is important for which means important for the surface to be free from impurities or have to be perfectly clean. In detail, the requirements of a specimen to use Knoop method are same as Vickers, which are: first, the specimen should be polished for micro-hardness testing or precision ground for macro-hardness testing. The second is the specimen should preferably be clamped strongly so that it cannot move during the testing process. And in addition, to avoid affecting the test result, care must be taken to make sure that the test is not disturbed by any kind of shock or maybe vibration. We can use an anti-vibration table as the alternative. Thank you. Hi, this is EP. Now I want to explain about the Knoop methods and applications. Knoop method is rather long and narrow and less deep compared with the broader and the rounder Vickers indentations. The Knoop method is primarily suitable for testing faceted layers, for example aluminum foil, as well as hard and brittle materials such as glass and ceramics. Why the brittle materials use Knoop method? Because if they use Vickers method, which has deeper indentation than Knoop method, it will make the cracks around the edges of the materials, which can be avoided if they use shallower Knoop indentation. From a geographical perspective, the Knoop method is used above all in the USA, while it is less common in Europe. As you can see in the table, there's like the applications of Knoop method is used for faceted layers, embedded specimens, and serial measurements. And the indenter is a diamond pyramid. As you can see in the picture on the right, this one is 172 degrees and this small one is 30 degrees. Thank you.
Next, I will explain the Knoop method testing. 1. Vertex. Vertex, the first, enables the knob in the stiffer to rest narrower and thinner areas of Vickers. Second, the knob hardness test was developed as an alternative to the Vickers test to overcome crack in testing brittle materials such as ceramic. 3. This core method is suitable for thin, small specimens or alternating to brittle during testing. 2. Next, knife dispenser. The first must ensure that the surface of the specimen is polished free until small. Second, cause isolate time will produce an indentation with a diagonal length or more than 20 mm. 4. Small index tend to be difficult to measure accurately.
Hello, if it's here. Now I want to explain about the comparison between Knoop and Vickers method. So basically, Knoop method represents as the alternative to the Vickers method. And here are the comparison between both of them. The first is with an identical test slot, the Knoop diamond indenter penetrates the specimen only half as deep as the Vickers diamond indenter. Due to this shallow indentation depth, the Knoop method is more suitable for testing very thin layers, as example, aluminum foil. Second is, due to the long and narrow test indent, the Knoop method is best suited for use with small, longish kind of specimens, while the Vickers method is better for small, rounded specimens. And the third is the Knoop method is particularly suitable for testing very hard and brittle materials, for example, glass and ceramics, where the Vickers indentation would lead this kind of materials to crack. Why? Because Vickers indentation is more deep than the depth of the Knoop method, so those kind of materials will sure break so easily if they use Vickers methods. Yeah, I think that's enough from us. In conclusion, Vickers and Knoop hardness tests are just two from many other ways to test the hardness of a material. Vickers and Knoop method are not the same, but they do have many similarities. And basically, Knoop method is the alternative of the Vickers method. Thank you, Miss Ami, and thank you for any of you that maybe watch this video. Thanks for listening until this one. I hope we can meet each other soon enough. Stay healthy!